Hello homeschoolers! Welcome to Science Class, the new normal edition. I am Teacher Gwen and join me today as we learn new things and new concepts at the comfort of your home. For today's learning objectives, first we will trace the discovery of the different subatomic particles and describe how different scientists improve the model of atom. So after John Dalton, the scientists never stopped exploring the existence of atom that leads to the discovery of the different subatomic particles. In 19th century, physicist J.J. Thomson or Joseph John Thomson began experimenting with cathode ray tubes. Cathode ray tubes are sealed glass tubes from which most of the air has been evacuated. So this is how cathode ray tube looks like. A high voltage is applied across two electrodes at one end of the tubes, which causes a beam of particle to flow from cathode, so this one is the cathode, to anode. Okay? So, cathode is a negatively charged electrode. Okay? That's why it has this negatively charged or negative symbol. And anode is a positively charged electrode. Okay? So, to test the properties of the particles, Thomson placed two oppositely charged plates around the cathode ray. So this one, we have here the positive plate above and the negative plate below. Okay? And to his surprise, okay, once na na-on na niya yung high voltage of electricity, again, it will flow from cathode going to the anode electrode. Now, what happens is, nagkaroon ng deflection. Okay? Yan, na-deflect siya. Why is that? Instead na diretso dapat yung kanyang flow is dumikit siya or umakyat, nagkaroon ng deflection, nagbend yung ray ng light papunta sa negative plate. Okay, why is that? So he concluded that cathode ray bears negatively charged particles because negative is attracted to a positive charge, right? So he concluded that these particles composed of negatively charged particles. Remember sa magnets, di ba? So sa law of attraction, positive attracts negative and negative attracts positive, vice versa. But when you join a positive to a positive sign or negative to negative sign, nagkakaroon ng tinatawag na deflection. So ganun yung nangyari dito sa experiment ni J.J. Thomson. Nag-deflect yung negatively charged particle sa isa pang negative. Okay? So, kasi pinag-join niya yung isang negative at isang negative. So, nagkaroon ng deflection or bending of light. At yung light ay dumikit or sumama sa positively charged particle. So, dahil dyan, J.J. Thomson concluded that there is a positive or there is a negatively charged particles among these rays of light, and he called that one as electrons. Okay, electrons is a negatively charged particles. Thomson knew that atoms had an overall neutral charge. So when you say neutral charge, equal yung kanyang charges. Therefore, he reasoned that there must be a source of positive charge within the atom to counterbalance the negative charge on the electron. So he knew that there is a positively charged particle within that, but then naka-counterbalance niya yung negative charge, which is the electron. And this lead Thomson to propose that atoms could be described as negative particles floating within a soup of diffused positive charge. So this model is often called the plum pudding model of atom. Okay? So it is called the plum pudding model, ayan, due to the fact that this model, okay, the description of this model, as you can see, it is very similar to the plum pudding, which is a popular dessert in England. So, para siyang cookies, no? Ito, parang cookies. So, again, yung kanyang description, yung negatively charged particles are floating in a soup of a positively charged particles. And in his model, Thomson's plum pudding model of atom had negatively charged electrons embedded in a positively charged soup. Okay? So, again, yung model ni J.J. Thomson, ang kanyang na-discover na subatomic particles is the negatively charged particles, which is the electron. Scientists continued to investigate the structure of atom, including testing the validity of Thomson's plum pudding model. So, syempre, maraming mga scientists ang po-kontra at gagawa rin ng kanilang mga experiment. And the next groundbreaking experiment in the history of atom was performed by Ernest Rutherford in his company. So, hindi lang siya mag-isa dito. A physicist from New Zealand who spent most of his career in England and Canada. So, he was a student of J.J. Thomson and became interested with uranium and thorium, radioactive elements. So, Ernest Rutherford discovered protons, a positively charged subatomic particle, through his gold foil experiment. So, paano niya ba ginawa yung kanyang experiment? In the famous gold foil experiment, Rutherford fired a thin beam of alpha particles at a very thin sheet of pure gold. So, in this illustration, this one is the source or the alpha particle. So, alpha particle bears positive charge, and this one is the thin sheet of gold. So, gold, symbol ng gold ay AU. So, lagay natin dyan, AU. Okay. Now, since this one is a positively charged particle, that means yung light na magpapass through dyan, yung dadaan dyan na light, ay all of it are positively charged. Okay? So, Rutherford predicted that most of the alpha particle would pass through, okay, the thin sheet of gold. Okay, so yun yung kanyang prediction. This is because the positive charge in the plum pudding model was assumed to be spread out, okay, throughout the entire volume of atom. So, balikan natin yung model ni J.J. Thomson kanina, di ba? So, para siyang cookies, di ba? Wherein, kung nasan yung mga negatively charged particle is nandun din yung positively charged particle. So, nakaspread lang din sila. Okay, so ganun yung gustong patunayan ni Ernest Rutherford. Okay, pinapatunayan niya or gusto niyang i-prove na magkasama lang or nakaspread out lang din yung positively charged particle at saka negatively charged particle. But, the result of this experiment, okay, however, were striking. Okay? While, bakit naging striking siya, no? While most of, or almost all of the alpha particle passed through the straight line in the gold foil, few alpha particles were deflected more. Okay? Nagkaroon ng tinatawag na deflection. Remember, sabi natin kanina, si alpha particle ay positive charge. Okay, so once na nag-enter dyan yung light, okay, marami daw sa mga light ay tumagos lang, ay nag-pass through lang daw siya. Pero may mga light na nagkaroon ng bounce back na tinatawag, nag-bounce back or nagkaroon ng deflection. And some of the deflection is almost 90 degrees. Okay? Pag 90 degrees, kung saan sila nanggaling, dun din sila babalik. Okay? So, ganun yung nangyari. Okay? Again, ang expectation ni Ernest Rutherford ay tatagos lang yan lahat. But then, ito yung naging resulta ng kanyang experiment. So, bakit kaya ganun yung resulta ng gold foil experiment? So, in a closer look, this one is the alpha particle. Okay? So, once na yan, dumaan dyan yung light, dire-diretso lang daw siya. But, once na yung alpha particle, na-hit niya yung gitna, okay, yung center part ng atom, ng gold foil, nagkaroon ng deflection. Okay? Ba't kaya nagkaroon ng deflection kung na-hit yung gitna? Anong meron sa gitna ng atom or sa center ng atom? Okay? Again, remember, alpha particle is a positively charged particle. Okay? Balikan natin yung law of magnet, di ba? Positive attracts negative. Okay, once na pinagsama yung positive and negative, magkakaroon ng tinatawag na attraction. But once you combine positive charge and a positive charge, or a negative charge and a negative charge, nagkakaroon ng tinatawag natin na deflection or repulsion. Okay, so ito yung nangyari sa experiment ni Ernest Rutherford. Since alpha particle is a positive charge, once na nakahit siya ng kapwa niya positive, which is within the center of this atom, okay, nagkakaroon ng tinatawag na repulsion, nagre-repel siya. So, his findings, Ernest Rutherford, sabi niya, the positively charged particles are concentrated at the center of the atom. Nasa gitna ng atom ang mga positively charged particles. Based on his experimental results, Rutherford made the following conclusion about the structure of atom. So this is a summary of his conclusion. First one, the atom has a central core called nucleus. So ito yung lagayan or ito dito nakalagay yung mga positively charged particle. Okay, yung tawag natin sa central part of the atom is the nucleus. 2. Since most of the alpha particles pass through, an atom was largely made up of empty space. So mostly, wala talagang laman yung atom sa paligid niya kasi nasa pinaka-center yung proton, which is the positively charged. Third, inside the nucleus is the positively charged particles called the proton. So, yun yung kanyang residence, no? Nasa gitna. Again, si proton ay nasa gitna, nasa loob ng nucleus. Fourth one, the charge of the nucleus is positive since it contains proton. So, syempre, dahil nandun si proton sa nucleus, positive yung charge ng nucleus. Fifth, the nucleus are very small compared to the volume of atom. So, sobrang liit lang niya, gatuldok lang ang nucleus compare mo sa size mismo ng atom. So, sobrang liit lang niya. And 6, electrons are found outside the nucleus. So, yung electrons pala nasa labas ng nucleus, doon lang sila sa labas, pag-alagala lang doon. Okay, so yun yung findings ni Ernest Rutherford. In 1919, Rutherford had discovered the proton, a positively charged particle within the atom's nucleus. But they and other researchers were finding that proton did not seem to be the only particle in the nucleus. It is remarkable that neutron was discovered until 1932 when James Chadwick used scattering data to calculate the mass of this neutral particle. Since the time of Rutherford, it had been known that the atomic mass, okay, of the nuclei is a bit more than twice than the atomic number of most of that, okay, atoms. Essentially, all of the mass of the atom is concentrated relatively in the tiny nucleus. So, the discovery of neutron, okay, nagkakaroon kasi ng parang nagkakaroon ng miscalculation between the atomic mass and the atomic number, no? Kasi masyadong malaki yung atomic mass at hindi nagmamatch sa atomic number niya. Atomic number is equal to the number of electron, and number of electron must be equal to the number of proton. So, kung hindi equal yung dalawang yun, may mali. Okay? So, may kulang. So, ito yung sinagot ni James Chadwick through his calculation. Okay? So, he discovered neutron, a subatomic particle that has no charge or neutral. So, ito rin siguro yung naging dahilan kung bakit natagalan yung mag-discover ng neutron. Kasi nga, there's no way to find or to discover this subatomic particle. Kasi nga, hindi siya positive, hindi siya negative. So, hindi mo mai-apply yung law of attraction and repulsion, diba? So, at least, nalaman or na-discover siya through mathematical computation. So, these are the different subatomic particles and their corresponding mass or atomic mass unit, AMU. Electron, discovered by J.J. Thomson. Ang kanyang mass ay 0.00055 AMU. A proton, discovered by Ernest Rutherford. Mass 1.00727. And neutron, discovered by James Chadwick. Mass 1.00866 AMU. So heaviest C, neutron. So siya yung pinaka-heaviest subatomic particle. So proton and neutron, magkasama sila sa loob ng nucleus. Okay? So nasa loob sila ng nucleus. Tandaan yan na. And electron, okay, nasa labas lang. Now, after the discovery of the different subatomic particles, okay, scientists, hindi pa rin sila natatapos sa pag-discover, no? Okay, ngayon naman, ang naging question nila is the position of the electrons outside the nucleus. So, here comes the planetary model of atom. So, the proponent or the one who proposed this planetary model of atom was Niels Henrik David Bohr, or in short, Niels Bohr. He proposed the planetary model of atom, and he viewed that atom can be compared to the solar system, wherein the nucleus, okay, ito daw yung nucleus niya, yung nucleus, can be compared to our sun, okay, to the sun, and the electrons can be compared to the planets in the solar system. Kaya, sabi niya, okay, planetary model of atom can be applied to, or the solar system can be applied to the planetary model of atom. So, these are the different important features of the planetary model of atom by Niels Bohr. First one, in an atom, electrons revolve around the nucleus in a certain definite path called the orbit or the shells. So, ito, say for example, ito yung electron natin, and yung pathway na iniikutan niya is called orbit or shell. Okay? So, each orbit consists of electrons. Depende kung ilan yung laman niya. Second, each shell corresponds to different energy level. So, kada orbit or kada shell, okay, meron silang kanya-kanyang energy level. And ground state is the lowest energy level that is nearest to the nucleus. So this one, siya yung pinakamalapit sa nucleus. So siya yung pinaka-lowest ang kanyang energy level. So we can describe it as 1 energy level. Yung sumunod sa kanya, 2, 3, and so on. So habang lumalayo sa nucleus, tumataas din yung kanyang energy level. Fourth, when the electrons absorb extra energy, it becomes excited. Okay, so an electron can be excited or can become excited if it is given extra energy, such as if it absorbs a photon, okay, or packet of light, or collides with a nearby particle. So, nagiging excited yung isang electron once na na-trigger siya or naka-absorb siya ng extra energy. Now, excited electrons can be or can jump from lower energy level to higher energy level. So, say for example, meron tayo ditong isang electron. Okay? Once na naging excited itong electron na to, ang energy level nito, by the way, is 1 dahil malapit siya sa nucleus. So, once naging excited itong electron na to dahil naka-absorb ng extra energy, pwede siyang mag-jump o lumipat sa higher energy level. Okay? So, pwede siyang lumipat dyan. But, this electron cannot stay long. Okay? Hindi siya pwedeng mag-stay dyan ng matagal because of the extra energy na meron siya. Okay, kaya lang siya nandyan. But once na nawala na yung energy na yun, na-consume na niya, then babalik siya sa original state niya. Okay, so ganun yung nangyayari. So, paano malalaman na na-consume na niya yung kanyang extra energy? Once na nag-emit na siya ng light. Okay, so nag-release siya ng light. So, ibig sabihin na na-consume na niya yung kanyang energy. Then, babalik siya sa original niya state. Okay, that is in number 6. Okay, so the next part is the development of quantum mechanical model of atom. Louis de Broglie proposed that electron, which is thought as a particle, could also be thought as wave. So, this one is known to be the dual property of light, which is could be thought as a wave or particle. Next is Werner Karl Heisenberg, who proposed the uncertainty principle, which states that for a very small particle like electron, its location cannot be exactly known and how it is moving. Therefore, as we learn more about the electron's position, we know less about its energy and vice versa. So, it is hard to imagine not being able to know the exact location where a particle is at a given moment. Okay? It seems natural that if a particle exists in a space, then we cannot point to where it is. This is because of the wave-like nature of a particle. A particle is spread out, okay, over space so that there simply is not a precise location, okay, but instead it occupies a range of position. So, mas malaki yung nasasakop niya instead of knowing the exact location of it. Pwede mong sabihin na nandyan siya sa region na yan, but the exact location of the electron cannot be known. That is under the uncertainty principle. Uncertain means not sure. You are not sure, diba? So, yun yung proposal ni Werner Karl Heisenberg. Another scientist is Erwin Schrödinger. He used the wave-particle duality of electron to develop and solve a complex mathematical equation that accurately described the behavior of the electron in a hydrogen atom. So he used hydrogen atom in his study. Schrödinger wave equation replaced the Bohr ideas about electron location with an uncertain factor. He stated that electrons do not move in set paths around the nucleus, but in waves. So, ina-against or ina-oppose niya yung belief ni Niels Bohr that electrons are moving around the nucleus in a straight path, but instead, electrons are moving around the nucleus in a wave-like manner. Okay? It is possible or it is impossible to know the exact location of the electron. Instead, we had clouds of probability called orbitals in which we are more likely to find the electron. That is Erwin Schrödinger's belief. Okay, so this one is the birth of the quantum mechanical model that views electrons are cloud of negatively charged particles having a certain geometric shapes. So in this model of atom, it shows how likely an electron could be found in a various location around the nucleus. And it shows that the darker the area, the greater the probability of finding the electron. Okay, so in this illustration, okay, parang that's lang siya, no? So, the darker the region, that means mas maraming or mas possible na mas maraming electrons ang nasa region na yun. Okay, and this one is the nucleus. This is now the quantum mechanical model looks like. Scientists believe that somehow electron can be found in a region of space where it is likely to be found surrounding the nucleus, known as the orbital or atomic orbital. So now we have this atomic orbital defined as the volume or region or space around the nucleus where the electron is most likely to be found. Again, we cannot identify or we cannot locate the exact location of the electron, but instead we can find electron in a region wherein it is more concentrated, okay, by looking at the atomic orbitals. Okay, so now let's trace the different model of atom. Okay, so first is from John Dalton, so para siyang billiard ball. Okay, again, sabi niya kasi no, atom is already the smallest particle of all matter, okay, pero many scientists prove it wrong. Okay, under J.J. Thomson, okay, wherein he discovered the negatively charged particle, sabi niya that negatively charged particle are around or within the atom. Ay, yun lang, sabi niya, that there is a presence of negatively charged particle. Okay. Then, under ni Rutherford, okay, ni Ernest Rutherford, marami siyang nalaman, okay, that there is this central part of the atom called the nucleus, wherein within that center part of the atom lies the positively charged particle, which is the proton. And the electrons pala are located outside the nucleus. So, nandyan pala yung mga electrons. And then, Niels Bohr, ito na si Niels Bohr, he believed that atoms behave like the solar system. So, yung mga subatomic particles natin can be compared to the solar system, wherein the nucleus, yan, yung central part, yan yung nucleus, and yung mga electrons na to, they are moving around the nucleus. Okay? And then, Schrödinger, sabi naman ni Schrödinger, we cannot locate the exact location of the electron, but instead, there's a region, the atomic orbital, wherein we can find probably the location of the electrons. Okay? So, yun yung mga different model of atom. And ito na yung latest ngayon. We are now in the quantum mechanical model of atom. So, yun yung sinusunod natin ngayon. Thank you so much. If you have questions, feel free to ask. If you have clarification, just comment down below. Thank you.